In this video, we are going to discuss about how to identify function group from the given molecular formula. You might have seen this question in the sample question paper released by CBSE this year for term 2, okay, where you have been given with a molecular formula. Okay, the molecular formula means, as we know, like just represent the total number of atoms present in it. Okay, so it's given as a formula C2H6O, okay, where you have 2 carbons, 6 hydrogen and 1 oxygen. Okay, so you have to identify the what molecule it is, like whether it is what function group it has, whether it is the alcohol or aldehyde or ketone or carboxylic acid. You have to identify the function group from the given formula. Okay, so and then draw the electron dot structure or the normal structure, whatever it is. So this question is a kind of short question because many important topics from the chapter is being deleted. So we'll see how to find out the function group. So before that, you should know what all function group is there in the chapter with oxygen. Okay. Now look at this table. As you can see, with we have 4 function group with oxygen. One is OH. That's the hydroxyl group. The group is called hydroxyl. And any compound with OH, we call it alcohols. So one possibility of the compound, it can be an alcohol because it has 1 oxygen. Okay. Now the next function group is CHO. Okay, that's an aldehyde function group. Aldehyde function group. So any compound having this function group, we call it aldehyde. Okay, you should know the expanded structure of the CHO as well. So don't think like the H and O is being connected. Remember always the connection with carbon. H forms always single bond. Oxygen forms 2 bonds. So it's C single bond H double bond O. That's the expanded form of CHO. Okay, that is also contain 1 oxygen. So the given formula was C2H6O. Now it's very clear that this formula is having 1 oxygen. Okay, so it can be an alcohol because it has 1 oxygen. It can be an aldehyde because it has 1 oxygen. It can be a ketone, the CO group. That's a function group for ketones. It's similar to aldehyde, but both valency on either side of CO will be carbon, not hydrogen. If any valency around one of the valency around CO is hydrogen, it becomes aldehyde. If both remaining valencies are satisfied with carbon atoms, we call it ketone. Okay, so now COOH, it's very clear that this is carboxylic acid having 2 oxygens. So this formula cannot be a carboxylic acid because if carboxylic acid was present, it's supposed to be O2, right? There are 2 oxygens. So you have 3 possibilities. This compound could be alcohol or an aldehyde or a ketone. Okay, there are 3 possibilities. So how to decide that whether it is an alcohol or aldehyde or a ketone? So that's what we are going to discuss in this video. Okay, we'll learn it through a simple technique. Okay, suppose the question is this. Identify the function group. Along with that, they will be also asking to draw the structure of the like compound or the electron dot structure. If we know the structure, you can easily draw the electron dot structure. Okay, so before that, we know what is CH4, right? Methane, where carbon is being connected with 4 hydrogen atoms. It's a pure hydrocarbon because there is only carbon hydrogen present in it, right? So but just imagine if any other atom or group of atoms is coming other than carbon and hydrogen to this methane, the only way is it has to replace hydrogen, right? So but just imagine an OH functional group is coming, okay, and replaces the hydrogen. Okay, so it was CH4 before getting replaced, right? Now it is 1 hydrogen is replaced by an OH. Now it's CH3 OH. But the OH functional group that itself has 1 hydrogen, right? So if you take this hydrogen, if you count that hydrogen along with CH3, now it's back to CH4, right? Now there is what extra is there, then it's an extra O. Okay, so what is the CH4? That's the formula of the alkane, right? So this is the alkane formula. and along with that there is one oxygen. So in such cases, okay, you can say the compound is going to be an alcohol. So how to find out whether the compound is alcohol or not? It's very easy. Okay, what is the alkane formula? You just check for the alkane formula. We know the general formula of alkane. It is CnH2n plus 2. This is the alkane formula. So along with the alkane formula, if we found an O, oxygen with that, okay, so it's going to be always alcohol. Okay, now look at this question, look at this functional group. You have C2H6, so 2 carbons, okay, double plus 2, so 4 plus 2, 6 hydrogen. So it's an alkane formula. This is the ethane formula, 2 carbon like alkane. Along with that, 1 oxygen is there. So it's very clear that this is going to be an alcohol. The functional group is alcohol, that is OH. So identify the functional group means you can write OH. Here also this is alkane formula, like double plus 2. 3 carbons are there. So 3 carbon, the number of hydrogen is double means 6, 6 plus 2, 8. Then O. So it's alkane formula along with O. So that is also going to be an alcohol. Clear? So how to identify the alcohol? It's very simple. Okay, if the formula of the compound is an alkane formula along with O, it's going to be alcohol. Okay, for example, 1 carbon alcohol. Okay, so number of hydrogen will be double plus 2, so CH4O. It's a 1 carbon alcohol, that is methanol. Okay, now 2 carbon is then the number of hydrogen should be double plus 2, 6O. So it's going to be an alcohol. 3 carbon is double plus 2, 8 hydrogen along with O. It's going to be an alcohol. So that's a trick. You just look for alkane formula. If alkane formula is there along with O, it's always going to be alcohol. Okay, hope it's clear. Now, how to draw the structure? Sometimes you may ask to draw the electron dot structure or the normal structure. Both can be asked. So in the model paper, they asked for drawing the electron dot structure. So whether it is a normal structure or electron dot structure, it's better to draw the complete structure first. Okay, so how to draw that? Now it's very clear that this is the alcohol. It's fit into this alcohol formula, alkene formula plus oxygen. Okay, it's a 2 carbon alcohol. Correct? It's a 2 carbon alcohol. Now, how to draw the structure? Okay, so it's very, you can draw the functional group first. What is the functional group? OH. So when you draw, okay, because you want to draw the electron structure, just show all the bonds. Okay, so I'm just expanding. OH means, remember the connection between O and H is single bond, because H always in need of 1 electron, so always H forms 1 bond. So OH. Okay, now how many carbon is there? 2 carbon. So put 2 carbon here. 1, 2. So this is a 2 carbon alcohol. Okay, now satisfy the remaining valencies with the hydrogen. So only 1 valence of the carbon is used. So always, you know, there should be 4 bonds around carbon. Carbon always form 4 bonds to satisfy the octet electronic need, 8 electrons. So remaining 3 valencies should be hydrogen. Now the second carbon has utilized its 2 electron, now 2 remaining. So it should satisfy with hydrogen. Okay. Now you can count how many carbon, 2 carbon, how many hydrogen, 1, 2, 3, 4, 5, 6, including this OH hydrogen, 6 hydrogen and 1 O. Okay. And this is the structural formula of 2 carbon alcohol. Structural formula. Suppose if you ask to draw the electron structure, the first thing you should remember is, like, don't forget this, because the oxygen of the atomic number is 8. Okay. The electronic configuration is 2, 6. It has 6 valence electron. Out of the 6 valence electron, it need to make it 8, so it goes for like sharing with 2 other atoms. So oxygen always form 2 bonds to complete the octet. But out of the 6 electron, only 2 electron is going for sharing. So remaining 4 electrons are there. So there is 2 lone pair in oxygen. So always remember, there will be 2 lone pair. A lone pair means the electron which is not involved in bonding. They are free electrons. Okay, they remains in the atomic orbitals of oxygen. Okay, So always remember, whenever you are drawing like any function with oxygen, always remember there is 2 lone pairs in oxygen, because you need to represent that in the electron dot structure. Okay, so how to draw the electron dot structure? So if you have the structural formula with you, okay, it's very easy. Just draw circles like okay, we have 2 carbons, so this is 1 carbon. Okay, it's shared with other carbon, so there should overlap, because they're sharing, so they should have a common area, so they should overlap. So second carbon. While drawing oxygen, remember oxygen is like a bit smaller than carbon, so draw small, like a little bit small circle compared to carbon. And hydrogen is the smallest, so always it should be the small circle. Okay, so the first carbon has 3 hydrogens, second carbon has 2 hydrogen, and OH has 1 hydrogen. Okay, clear? Now, okay, so now how to fill the electrons? It's very simple. You can see a bond. Always remember, one bond means it's 2 electrons. So wherever one bond is there, put a pair of electron. Okay, so this is the hydrogen. In between C and H, there is a bond. So put 1 pair here. You can use dot or cross, it's up to you. Okay, now like other hydrogen, 1 bond, so 1 pair. Okay, CH bond, 1 bond, so 1 pair. In between C and C, you can see 1 bond, right? So put 1 pair in between C and C. Now second carbon also form 2 CH bond, so put 2 electrons. Okay, now there is a CO bond is also single bond, so 1 bond pair. Okay, the OH bond is also like put 1 pair. Now if you see hydrogen, no, hydrogen has only K shell, right? Its capacity is 2. So the maximum electron you will see around hydrogen will be 2. So you can see all the hydrogens. Okay, it's got 2 electron through sharing. And the carbon, now you can see carbon, it's acquired 8 electrons. Okay, this is 2, 4, 6, 8. Now look at oxygen. Oxygen has only 4 electrons around it. 2, 4. It should be 8, right? So because we are not showing the lone pair, so you should show the lone pair because it's not involved in bonding. You show inside the circle, not in the shade area. Okay. Now oxygen is also 8. Okay, clear. So this is the electron dot structure of a 2 carbon alcohol. Anyway, naming is deleted, but it's very simple compound. Okay, hope you know the general name of alcohol, ethanol. 2 carbon alcohol, generally we say alkanol. It's a 2 carbon alcohol, so ethanol. So this is the structural formula of ethanol. That's a 2 carbon alcohol. This is the electron dot structure. So always remember, if you asked to draw the electron dot structure, draw the normal structure first, then you can draw the electron dot structure by looking at that structure. It'll be easy. Okay, so hope you understood how to identify alcohols. What you should do, look for the formula. If it is an alkane formula, that is CnH2n plus 2. Okay, and if there is one oxygen coming along with that, we can easily say that the compound is going to be an alcohol. Okay, clear? Hope it's clear. Now how to draw the second one? Second one, that is C3H8O. So we know that it's an alcohol. How to draw the structure? So alcohol means the functional group is OH. Okay, now there are 3 carbons, so put 3 carbon in connection with oxygen. Okay, now each carbon should form like 4 bonds, so satisfy the remaining valencies with hydrogen. So already 1 bond is there, so 3 hydrogen. Now second one, only 2 bond is formed, so 2 hydrogen. Third one also, there is 2 connections being made, so 2 hydrogen. Now count the total carbon, 3 carbon, 1, 2, 3, 4, 5, 6, 7, including this 8 hydrogen. And the oxygen always has 2 lone pairs. So this is the structural formula of 3 carbon alcohol, that is propanol. Now if you know this, okay, you can easily draw the electron dot structure. I hope you understood. So now I'll go to the other functional group. Okay, now the same type of question, but the formula is different. Now look at this formula, C2H4O. Okay, so it's not alkane formula, right? Alkane formula is, if 2 carbon is there, it's supposed to be double plus 2, 6 hydrogen. but here is only 4 hydrogen is given, so C2H4. So the general formula, if there is N carbon, double hydrogen, so 2N. So this is the CnH2n formula, not CnH2n plus 2. So this is the alkene formula, ENE, right? ENE formula, the general formula of alkene, where compound with at least one carbon-carbon double bond is present. That's what alkene means. Now this is having an alkene formula along with an oxygen. So it cannot be alcohol, right? So if it is an alkene formula along with oxygen is found, there are two possibilities. The functional group can be an aldehyde or ketone. There are two possibilities. Okay, the functional group can be an aldehyde or ketone. Okay, now how to decide whether it is aldehyde or ketone? So suppose here it is given 2 carbon, right? So we know that for the simplest ketone, the functional group of ketone is C double bond O, right? C double bond O. And the remaining 2 valencies should be carbon for ketone. So the simplest ketone contains always 3 carbons. Always remember, the simplest ketone contains 3 carbon. So there is no ketone with 1 carbon, there is no ketone with 2 carbons. But you have aldehydes with like 1 carbon and 2 carbons. So the given formula is 2 carbon, right? So it cannot be ketone. It cannot be ketone, it's always aldehyde. So remember, if the number of carbon is, okay, if the number of carbon is like 1 or 2, if the number of carbon is 1 or 2, only aldehyde is possible with this formula. So if the formula is CnH2nO, and if the number of carbon is either 1 or 2, you have only aldehyde is possible, not ketone. No ketone is possible because the simplest ketone is having 3 carbons. Okay, understood. So in the first example, this is an alkene formula along with O, right? Along with O, alkene formula with O. So it can be 2 possibilities, aldehyde or ketone. The functional group can be either CHO, that is aldehyde functional group, okay, or it can be a ketone, okay, ketonic functional group. But it's very clear that there are 2 carbon. There is no ketone with 2 carbons. So ketone start from 3 onwards, 3 carbon onwards. So it's only possibility. The first one is going to be aldehyde. The function group is aldehyde. What is the aldehyde function group? CHO. But remember, whenever you ask to draw the electron dot structure, okay, to write, you can write function group as CHO, but if you ask to draw the electron dot structure, you should know how to expand this. Okay, the expanded form is required for drawing electron dot structure. Okay, so we'll see how to draw the electron dot structure for aldehydes. So what is the functional group? CHO. Why not ketone is possible with this formula? Because only 2 carbon is present. Ketone should have like minimum 3 carbon. Okay, now it's a 2 carbon aldehyde, right? So we just write the functional group CHO. Now remember, the functional group itself has 1 carbon. Okay, so we need 2 carbons. So add 1 more carbon. Now satisfy the remaining valencies with hydrogen. So 3 hydrogen we require. So this is the like 2 carbon aldehyde, CH3 CHO. Now if you ask to draw the electron dot structure, you need the expanded form. So where you have to expand the functional group CHO. So CH3 C, always remember the connection is made with carbon. All atoms are making the connection with carbon. So H is connected with the carbon, O is connected with the carbon. H forms always single bond, O forms double bond. So this is the expanded form. And whenever there is oxygen, remember there is 2 lone pair. Now, if you have this, you can easily draw the electron dot structure. Okay, so draw 2 carbons, share its electron with other carbon, so there should be a common area. Sharing area should be there. Then oxygen is there, which you can draw it a bit smaller than carbon. Okay, now you have 3 hydrogen. That's the smallest atom. Should be small circles. So 3 hydrogen connected to first carbon, and now second carbon have an oxygen and a hydrogen. Now just look at the normal structure, and okay, you can accordingly you can fill the number of required electrons. Okay, so hydrogen always forms 1 bond, so 1 pair with carbon. So all the CH bond will be always a single bond. So one pair. The carbon-carbon bond is also like a one pair, a single bond. Now with H, its kind of bonding forms one bond. With O, it forms a double bond. So it should be two pair. Two pair. One pair is single bond, one more pair double bond. So two pairs we require it. Okay. Now two lone pairs or not, that should be inside. Okay, that's the electron dot structure of like two carbon aldehyde. Okay, hope it's clear. So how to identify the aldehyde and ketones? Okay, it's very simple. Just look for alkene formula CnH2n. Okay, then if one option is there are two possibilities: aldehyde or ketone. If the number of carbon is 1 or 2, only aldehyde is possible. Ketone is possible only from 3 carbon onwards. 3 carbon onwards. Now look at the second example. Okay, you have 3 carbon here, and this is an alkene formula, double 3 carbon. So number of iron is 6, so just double. So it's fit into the formula CnH2nO. Okay, so there are two possibilities, right? Either aldehyde or ketone. Okay, so here the number of carbon is 3. So 3 means ketone is also possible. So both it can be an aldehyde as well as ketone. So you can draw both. Okay, you can write both possibilities. It can be an aldehyde or ketone. So they're isomers. The same formula but different structure, right? Different compounds. So they are like isomers. Okay, so how to draw that? So there are two possibilities. Okay, so you can draw aldehyde or ketone with this formula. So both are correct. So how to draw aldehyde? 3 carbon aldehyde. So aldehyde functional group is CHO. Okay. So now that remember the aldehyde itself has 1 carbon, function group itself has 1 carbon. Total 3 carbon should be there. So add 2 more carbons. Okay. Now satisfy the remaining valencies with hydrogen. 2 valencies be used. So 2 hydrogen. So look at the formula. How many carbon? Total 3 carbon. How many hydrogen? 1, 2, 3, 4, 5, including this 6. Now how many what left? 1 oxygen left. So an aldehyde is possible with this formula C3H6O. It's a 3 carbon aldehyde. Okay, 3 carbon aldehyde. Now like with 3 carbon you can also have ketone, right? So what is the ketonic function group? C double bond O. On either side of C double bond O it should be carbon. So minimum 3 carbon should be there. Okay, now satisfy the remaining valencies with the hydrogen. So 3. So middle carbon already 4 carbon has found 4 bonds. So no need of any hydrogen. So the terminal carbon has 3 more. Now count the hydrogens. It's very clear that like 3 carbon is there. How many hydrogen? 1, 2, 3, 4, 5, 6. H6. How many oxygen? 1 oxygen. Okay, so with the same formula, both aldehyde and ketone is present. Okay, so same formula, different structure. So these two compounds are isomers, examples for isomers. So with the given formula, you can draw 2 isomers. Okay, one is aldehyde, 3 carbon aldehyde, one is 3 carbon ketone. Now, how to draw the electron dot structure for this? Like that is also very easy. Like how many circle to be drawn? Like carbon is there 1, second carbon 2, then one more carbon 3. Each carbon, like the terminal carbon, has 3 hydrogens. So 1, 2, 3. Here also 1, 2, 3. Okay, so all these are carbon. Now you have 1 oxygen here. Okay, now satisfy the remaining valencies with like hydrogen. That's it. So CH3 and all the bonds are single bonds. So always remember H forms only single bond. So put 1 pair. 1 line means put 2 electron, 1 bond. Okay, so CC single bond. Now remember CO is double bond. So put 2 pair here. Put 2 here. Sorry. Put 2 here. Okay. like 1, 2. It's a double bond, so 2 pair. Okay, and always remember whenever you're drawing oxygen, like there should be 2 lone pairs. So don't forget that. Okay, so already we drawn one for aldehyde. So I'm just showing for ketones. Okay, now hydrogen. Okay, so this is the electron dot structure of the 3 carbon ketone. Okay, so how to identify aldehyde or ketone? You look for alkene formula CnH2n, then see whether one oxygen is present. That's going to be aldehyde or ketone. Remember, if the number of carbon is either 1 or 2, it's only aldehyde is possible. If n equal to 3 onwards, both aldehyde and ketone is possible. So they are going to be isomers. Okay, clear? Then the last functional group with oxygen, that is like, it's very clear. This is very easy to identify because you can see in the formula there are 2 oxygen, right? So we have like studying like functional group with oxygen. One is OH, one is CHO, one is ketonic function group, C double bond O. So all this, the 3 we just saw is having only 1 oxygen, right? Now there are 2 oxygen in the compound. So there is only one functional group with 2 oxygen, that is COH. So it's very easy, right? Okay, so it's surely going to be carboxylic acid. So mostly they won't ask because it's very easy to identify carboxylic acid. Okay, so mostly alcohol or aldehyde or ketone is more chance to ask. Okay, so how to draw the structure? It's very easy, like COOH is a functional group. Remember, COOH means it's a combination of 2 functional groups. It's a ketone functional group is a CO along with an alcohol functional group OH. So always remember this when you split COOH. There is a C double bond O is present as well as there is an OH is present. So there is 2 functional group is present. Okay, it's a combination of 2 functional group, CO plus OH. Okay, CO is called carbonyl group. Carbonyl group. Both aldehydes and ketones have this group, C double bond or carbonyl. OH is called hydroxyl group. Hydroxyl. So since it contained together, okay, it becomes carbo from carbonyl, HYL from hydroxyl, so it becomes carboxyl. Okay, so that's why COH got the name carboxyl group, carboxylic group. Okay, because it's contained carbonyl plus hydroxyl. Understood? So I hope it's clear. You like how to draw the structure, the normal structural formula. So it's 2 carbon, right? So remember the functional group itself has 1 carbon. Now only 2 like yeah, it's given only 1 carbon. So remember the functional group itself has 1 carbon. Okay, so you cannot put 1 more carbon here. Then it's become total carbon become 2. So it's not possible. So how to draw the structure? So COOH itself has 1 carbon. Now you cannot put carbon here. So only possibility is you can put hydrogen. So that's the first carboxylic acid, 1 carbon carboxylic acid, HCOH. Okay. So how to expand this? It's C double bond O OH. Now it's very clear that 3 valencies of the carbon is being used. Only 1 valence is free. That's why we are satisfying with hydrogen, HCOH. That's the first carboxylic acid. Okay, 1 carbon carboxylic acid. Okay, always remember there is 2 lone pair on oxygen. Now how to draw the electron dot structure? Okay, so put a carbon, this is your carbon. It's connected with 2 oxygens. Okay, now the satisfy the remaining valences. You have a hydrogen here. It forms 1 bond. Okay, the oxygen forms a double bond. So put 2 pair. Inside there should be 2 lone pairs. Okay, now the other carbon is connected to oxygen with 1 pair and there's no OH bond. Clear? Now like 2, 4, 6, 8 should be 4 electrons inside. Okay. Now look at carbon. It's 2, 4, 6, 8 electrons. So every atom satisfied their completed their electronic need through sharing. So that's the first electron dot structure of the first carboxylic acid. So always remember, you have to draw the structural formula before drawing the electron dot. By looking at the structural formula, you can easily draw the electron dot structure. Okay, how many pairs are required in between atoms is easily you can find out. Okay, from the structural formula. Okay, now we'll do the second question. Hope it's clear. The second question is a 2 carbon it's O2, right? So only one possibility, COOH. So it's a 2-carbon acid, carboxylic acid. So the functional group itself has 1 carbon. Now there are total 2 carbons, so add 1 more carbon, satisfy the remaining valencies with hydrogen. So CH3, COOH. Okay, it's an important acid. It's called acetic acid, or kind of like dilute acetic acid, is known as vinegar. So sometimes this may be asked. So it's a vinegar, or dilute acetic acid is known as vinegar. It's a 2-carbon acid. Okay, it's ethanoic acid or acetic acid. Anyway, formula is the naming is not required, but still it's an important common name, acetic acid, 2-carbon acid. Okay, how we expand this? C double bond COOH, it should be C double bond O. Always there is lone pair on oxygen, and OH, 2 function group, double bond O plus CO plus OH. Okay, now satisfy the remaining valencies. So this is the complete structural formula. By looking at this structure, you can easily draw the electron dot structure. Okay, so I hope it's helped you to find out the functional group. Okay, so how to find out the functional group? Just look at the formula. If you found 2 oxygen, okay, so it's very easy. The functional group is COH because there is 2 oxygen. If there is only 1 oxygen in the molecular formula, you have 3 options. Okay, either aldehyde or ketone or alcohol. Okay, so how to decide which is a functional group? It's very easy. Look at that hydrocarbon part. Okay, the formula is fit into alkane formula. So this is 1 carbon, 2 hydrogen. So it's fit into alkene formula. Okay, alkene formula means like there are 2 possibilities, right? Aldehyde or ketone. But how many carbon is here? Only 1 carbon. So ketone, you cannot have a ketone with 1 carbon. So this is aldehyde, CHO. Okay, second one, you can see 1 carbon, 4 hydrogen. So it's 1 carbon, 4 hydrogen means it's double plus 2. Okay, so it's an alkane formula with O. Alkane formula with O means it's always alcohol, OH. Now C4H8O, that is alkene formula plus O, right? So it can be, there are 4 carbons. So both aldehyde and ketone is present. So they are you can draw isomers with the same formula. Okay, I hope this will help you to find out the functional group. We'll be coming with more videos very soon. Okay, so please support. Thank you so much.